So in this video, we're going to look at some derivative rules being applied with logarithms. Okay, so in this first example, we're going to compute the derivatives of three different expressions. So the first expression is going to be 6 times the natural log of x. Second expression is going to be 6 times log base 5 of x. And the last expression is going to be x times the natural log of x. Okay, so in the first expression here, the 6 is just a coefficient. So when we take the derivative of this, we're going to ignore the 6 and we're going to take the derivative of the natural log. The derivative of the natural log is 1 over x, so we'll get 6 over x is our answer. In a similar fashion, we're going to ignore the 6 in this second expression and just take the derivative of log base 5. The derivative of log base 5 of x is 1 over x times the natural log of the base, and the base is 5. So we'll have 6 over x natural log of 5. And then in this last expression, we have a product. So you might be tempted to write 1 times 1 over x. That's not correct. We need to use the product rule here. So we'll take the derivative of x, leaving the natural log alone, and then we'll take the derivative of the natural log, leaving the x alone. We'll compute these products and then put them together. So the derivative of x is 1, and the derivative of natural log of x is 1 over x. So we'll get the natural log of x plus x times 1 over x, which is 1. Which simplifies to natural log of x plus 1. Okay, so let's look at a slightly more difficult example. So we're going to compute derivatives of the following. So the first one is going to be the derivative of the natural log of x cubed minus x squared plus 6. And the second one is going to be the derivative of the natural log of x minus x all cubed. Okay, so in this first part A, we're going to have a function, a polynomial, inside a natural log. And so this is going to be using the chain rule. The chain rule applies here. And you'll recall that the chain rule, when we apply the chain rule, we take the derivative of the outside, so the derivative of natural log. The derivative of natural log is 1 over x. And then we leave the inside of that function alone. The inside of that function is this polynomial. So we're just going to write 1 over the polynomial. And then we multiply by the derivative of the inside. The derivative of x cubed plus or minus x squared plus 6. And that's going to work out to be 3x squared minus 2x. All right, in the second part here, we have the natural log of x minus x inside this cubed function. So we'll take the derivative of the outside, the derivative of x cubed, or this cube function, which is 3 inside squared. And then we take the derivative of the inside. So we multiply by the derivative of the natural log of x minus x. And the derivative of the natural log is 1 over x, and the derivative of x is 1. So this becomes 1 over x minus 1. All right, let's do one more example. So in this example, we're asked to find the equation of the tangent line at the point x equals 1 over 6 when the function of interest is 3 natural log of 6x plus 8. So I don't know what this function looks like. Let me just let me just do a guess on what it looks like. Let's say it looks something like this. And we're looking at the point 1, 6. Let's say this is our point 1, 6. And we're trying to find the tangent line here. So we need to first find the slope of this line. We can find the slope by taking the derivative. And then we're going to use this point 1, 6, and whatever the function outputs at 1, 6, f of 1, 6, and that slope to find the equation of the line. So let's start by taking the derivative. So the derivative of this function is 3 times 1 over 6x, derivative of the outside leaving the 6x alone, and then times again the derivative of 6x, which is 6, plus 0. Derivative of 8 is 0. Simplifying this a little bit, the 6's cancel, and we'll be left with 3 over x. So the derivative of this function is 3 over x. That gives us the slope at all points. We want to find the slope at the point 1, 6. So that's going to be 3 over 1, 6, which is 18. Okay, so what we know here is that the slope of this line, the m, is 18. So slope is equal to m is 18. All right, now we want to find a point on this line. Okay, so we're going to put 1, 6 into the function and figure out the y value, the corresponding y value. So we'll get 3 times the natural log of 6 times 1, 6 plus 8, which is 3 times the natural log of 1 plus 8. The natural log of 1 is 0, so that outputs just 8. So our point here, our point is 1, 6, comma 8. Okay, so now we have a slope and a point. We can use the point-slope form of the line, which I'll write over here, and put those numbers in. So we'll have y minus 8 equals 18x minus 1, 6. So if we solve for y, we get y equals 18x. 18 times 1, 6 is 3, so minus 3, plus that 8 from the left-hand side, which gives me y equals 18x plus 5. So that is our tangent line. All right, I hope you found this video useful.